Hello everybody! Welcome to another maths lesson. This week we are going to practice a lot of the skills and knowledge that we're going to need to go on and succeed in multiplication and division and fractions as well in year 5. And we're going to today look at what multiples are in maths, and just practice some work about Venn diagrams. Well, I've got our starter here looking back at what we were learning before, which was all about factors and the product. So pause the video and have a go at these questions. Before you start them, remember, a factor times a factor makes a product. And there are 3 questions. What are the factors of 12? What is the product of 3 and 6? And then I am thinking of 2 numbers. Their product is 20. What 2 numbers could I be thinking of? Have a go. Pause the video, please. Have a go. Okay, I hope you paused the video. So remember, what are the factors of 12? Well, let's look at this. Factor times factor makes the product. So this question means the factors of 12 means the number times the number, which makes 12. Remember what we did, working systematically. Start with 1. Well, 1 times 12. Okay, 12 is even. I must just say, looking at your work, quite a lot of you forgot that for every number, 1 is a factor, because every whole number is on the 1 times table. Then 12 is even. So after 1, I'm thinking 2. Got to be a factor of 12, because 12 is an even number, which means it's on the 2s, 2 and 6. After 1, 2, I'm working systematically. 3 times 4 is 12. Okay, 5, no. 5, 10, 15. 6, we've done 6 already. We don't need to keep going past halfway because we've caught them all now. So the factors of 12, I'll write in my answer. Factor pairs, 1 and 12. 2 and 6, 3 and 4. What is the product of 3 and 6? Oh, remember, something times something makes the product. So this question means when I multiply, because product is a word to do with multiplying, when I multiply 3 and 6, 3 times 6, the product is 18. So the product of 3 and 6 is 18. I'm thinking of 2 numbers. Their product is 20. What 2 numbers could I be thinking of? Well, it's another factors question. So I'm going to work systematically. 1 and 20. After 1, 2. 2 and 10, because remember, the product is 20, so 1 times 20 is 20. 2 times 10. 20 is not on the 3s, it is on the 4s. 4 times 5, so it's on the 5s. It's not on the 6s, it's not on the 7s, it's not on the 8s, not on the 9s, the 10s, but we've done that one already here. Those are the 2 numbers I could be thinking of. I could be thinking of 1 and 20, or 2 and 10, or 4 and 5. Okay, so just remind ourselves, we're looking at this word multiples. And when we say the word multiples, we can probably hear it's something to do with multiplying. That makes sense. Multiples, multiply, multiplication. Okay, so here are some of the multiples of 6. Well, I've got a number track here. Can you see it? 0, 6, 12, 18. These are some of the multiples of 6. So pause the video. What do you think we'll put here and here? Can you see the pattern? Okay, it's the 6 times table. We're counting in sixes, aren't we? Add 6, add another 6, or if you like, we're saying 1 times 6 is 6, 2 times 6 is 12, 3 times 6 is 18, so this one must be 4 times 6, 24, and then 35 times 6. Oh, but look down here. We have got some negative numbers, which are also multiples of 6. So, let's say what we've learned so far. When we talk about the multiples of 6, all the numbers on the 6 times table, including 0, are multiples of 6. Remember, 0 times 6 is 0. So, 0 is on the 6 times table, so it's a multiple of 6. Now, counting back, taking away 6, 0 minus 6, oh look, these are the negative multiples starting. Minus 6, minus 12, minus 18, and it would continue. Minus 24, minus 30, minus 36. So we have all the numbers on the 6 times table, including 0, and don't forget the negative multiples of 6. So, the multiples of 6 include the products that we learn on the 6 times table, 6, 12, 18, 24, 30, 36. But it doesn't stop here. 72 is not the last of the multiples of 6. Remember, 0 is a multiple of 6, and also the multiples of 6 never stop going. Because if we keep counting up in sixes, past 12 times 6, those numbers are all multiples of 6 as well. So, 12 times 6 is 72. But the next one, 13 times 6, well, 72. Add 6, because we're counting in sixes, makes 78. Then if we do 78, add 6, then we've done 14 times 6 is 84. And we keep on counting. 90, 96. Okay, those are all multiples of 6 as well. And in fact, any whole number times 6 will give us a multiple of 6. So something is a multiple of 6 if we can take a number. I'll choose any whole number, any integer. Integer means a whole number. 1 or minus 1. 2 or minus 2. But not 1.5, because that's not a whole number, and not 1.1, because that's a decimal number. That's not exactly a whole number. So I'll take a whole number, an integer, like 20. 20 times 6. So 2 times 6 is 12. I'll make it 10 times bigger because we're talking 2 tens. 120. Oh, that's a multiple of 6. We multiplied a whole number by 6. We got 120. That's good. Pause the video here. See if you can answer these first questions just on a rough piece of paper. Have a go. Oh, I should have said these are the multiples of 3 that we are talking about now. Did you pause the video? Did you have a go? Hope so. So, don't forget, starting with 0. 0 is a multiple of 3. 0 times 3. 3, 6, 9, 12, 15. Ooh, don't forget your negative or your minus multiples. Minus 3, minus 6, minus 9. And of course, that would go on that way as well. Ooh, 60 is the multiple of 3 because... How do we know? Well, because I can think of the number 20 times 3 is 60. So I could take a whole number, an integer, times it by 3, I make 60. So 60 is a multiple of 3. 33 is a multiple of 3 because 11 times 3 equals 33. 90 is a multiple of 3 because 30 times 3 equals 90. 600 is a multiple of 3 because 200 times 3 equals 600. Okay. Have a go at these questions. Remembering now we're talking the multiples of 4. Give it a go. Pause the video. Okay, so it's the same thing again, isn't it? We're saying 0, 4, 8, 12. It's the 4 times table. 16, 20. The negative ones that people often forget. Is 100 a multiple of 4? Well, yes, it is. 4 times 25 is 100. So 25 times 4 is 100. Oh, okay. Could 125 be a multiple of 4? What do you think? No. We learnt last week that all the multiples of 4 are even. 125 is odd. It's odd. All the multiples of 4 must be even. How can you make another multiple of 4? Well, think of any whole number, times it by 4. I might do 8. 8 times 4 is 32. Oh, 32 is a multiple of 4. So, one of the things we're going to do today is, for your work in a minute, is we're going to tick the numbers which are multiples of 7. So let's have a look at some of these. I won't do all of them, but 17. It's got a 7 in it. Does that make it a multiple of 7? No, it's got to be on the 7 times table. I've put the 7 times table here. 17 is between 14 and 21, so I will not going to tick that one. In fact, I'll put a cross. 35. Yeah. 5 times 7. Okay. 49. Yeah. Because it's 7 times 7. 71. No. Oh, what about 91? That's more than the 7s. But 12 times 7 is 84. So let me work out 13 times 7. I've got to do 84 add 7 is 91. So 13 times 7 is 91. 91 is. Ooh, you can probably work out the other ones. Don't forget what we said about 0. 0 is a multiple of 7. Okay. And here we have just our level 3 questions. And we're looking at Venn diagrams, interestingly, named after the English mathematician John Venn, who actually used the work a lot. But very interesting, John Venn was a very modest man, and he himself called them, I've written it over here, Eulerian circles, after Leonhard Euler, a very famous Swiss mathematician who discovered Euler's law and Euler's number. So, the job. Put each of the whole numbers from 0 to 20 in the correct place on this Venn diagram. So look, the red circle will where we put anything that is a multiple of 4. The blue circle is anything which is a multiple of 3. And then we have this space here, can you see it, which has got the blue and the red. If it's a multiple of 3 and 4, it goes in there. Okay, right, let's start with 0. So I've got to go through all the numbers. 0. Where am I putting 0? Well, it's on the 4s and the 3s, so it's got to go in the middle. 1. Is 1 on the 4s? No. Is 1 on the 3s? No. Oh, where does it go? Well, it's not a multiple of 4, it's not a multiple of 3, so we put it outside the circles. 1. Same thing for 2. What about 3? 3 is the first one on the 3 times table. It's a multiple of 3. Put it there. What about 4? 4 will go here. Okay, 5. Is 5 on the 3s? No. Is it on the 4s? No. Okay, so putting it here. 5. 6. 6 is on the 3 times table. Not on the 4 times table. What about 7? No. Do you see how it works? I hope so, because I know that Venn diagrams are things that we start looking at in year 3. So, your work today, the worksheet to have a look at, starts level 1, looking at the multiples of 5 and some questions about that. We better change that one there. I'll change that one on the sheets that I upload. So, got some questions there on level 1. Then we've got some numbers to investigate. Are they multiples of 4 over here? Are they multiples of 6 over here? And then a Venn diagram, the multiples of 2, the multiples of 5. So, good luck. I hope you enjoy it. And let me know if there are any problems on Google Classroom. Bye, everyone. See you soon.